In this tutorial, we're going to look at sketching functions, more specifically polynomials, although this can work with most functions, non-linear functions. So this includes polynomials of any degree. It also is going to include functions like exponential functions, logarithms, and trigonometric functions. But we're going to use an example and work through a simple polynomial today. So if we write the polynomial down, that's going to be y equals x cubed minus 3x. Now, if we just draw a sketch a graph, then we can add the information to it as we move along. The first thing we want to find out is where the graph's gradient is 0, i.e. where the graph is changing. And these are called critical points of inflection when the gradient is 0. To do that, we just take the first derivative when we look at where the first derivative equals 0, because obviously the first derivative gives you the gradient of the line. This is a pretty simple function to get the derivative of, so y prime is going to equal 3x squared minus 3. Now, once we figure out the values from the first derivative when a equals 0, that's going to tell us where the graph is changing. It's not telling you how the graph is changing. We can tell that from the second derivative. So if we just take the derivative again, and you'll see how that plays out in a minute. But for now, we'll just take the second derivative, which is going to be 6x. Okay, so let's equate the first derivative equal to 0 and see what values we come up with. So that's going to be 3x squared minus 3 equals 0. Now, we want to factorize this polynomial, and the easiest thing to do is pull out a factor of 3. So we'll have 3x squared minus 3, x squared minus 1. Okay, and now we've still got a square there, so we can factorize what's in the brackets quite easily. And we get 3x minus 1 x plus 1. And that's going to give us and that's going to equal 0. And then we can clearly see that equals 0 when x either equals 1 or minus 1. So we can see our stationary points are at x equals 1 and x equals minus 1. Now, the second thing we want to find, before we go on to finding what sort of curve that is, we want to find the corresponding y coordinate. So when x equals 1, if we plug that into our original function up here, we find that y is going to equal minus 2. Is that right? Yeah, that's right, minus 2. And here, when x equals minus 1, we're going to have a y value of minus 1 plus 3, which is going to be equal plus 2. So when x is minus 1, y will equal 2, so that's about here. And conversely, when x equals 1, y will equal minus 2, which is about here. So we know those are 2 points on the graph and points where the graph is changing, but we don't know what it's doing. So what we need to do now is plug in our x values into y prime prime, and then depending on whether it's positive or negative, because we're getting the slope of the slope, so we're seeing how the slope is changing, we'll find out what sort of inflection this is. So so when x equals 1, y prime will equal 6. So x equals 1, y double prime is going to equal 6. And when x equals minus 1, y prime prime will equal minus 6. Now, if we think about this, there's an easy way to remember it, but I'll go through it logically first. That 6 means the gradient of the graph, because it's positive, it means the gradient of the graph is constantly increasing through that point of inflection. So here we'll have a negative gradient. So the tangents here are negative, but they come in less negative. I'll choose a different color, it'll show up better. So that's negative, less negative, less negative, 0, positive, more positive. So when the second derivative is positive, that means the grade's always increasing, and we have a plus. We have a positive bowl. Now, when we have the second derivative being minus, we'll draw a little curve in again to show that. We can see that the gradient is very high, but it's less high, so it's decreasing. It's decreasing again, it goes to 0, and then it's becoming negative and more negative. So it's a an N shape or an umbrella shape. Now, an easy way to remember this is positive is happy, negative is sad. Smiley face, sad face. But anyway, we now know what the graph is doing at those points. So we know up here where x is negative, we have an unhappy face. And we know when it's positive, it is a happy face. But we still don't know where this crosses the y-axis. So to do that, we simply plug in x is equal to 0 up here, and we find y comes out as 0 as well. So we know it crosses the y-axis at 0 when x is 0. So we know it's going to cross this point here. Now, we know there's no other points of critical inflection, or no other points of inflection in this case, so we can sketch out our graph nicely like that. And we can label the points. So this point here is 1 minus 2, and this point up here is minus 2, sorry, is minus 1. Sorry about that. Is minus 1, 2. Okay, and now we've sketched a graph of a simple polynomial. With longer, bigger polynomials, it's exactly the same theory. Do exactly the same thing, just a bit more complicated, and you just have to keep your head about you and think about it. So yeah, hope you found this tutorial useful and enjoyed it. If you have, give us a like. If you've got any questions, post them in the box below. And of course, to keep up to date with our videos, hit the subscribe button below. Thanks for watching.